A squared plus B squared is 1.
Yes, a squared plus b squared is 1. A squared plus b squared. And what's the equation of this line?
Y equals negative B over AX plus B.
Y minus y1, for example, y minus b is equal to, or let's write y for this, is equal to the slope is negative b over a times x minus a, right? So we can say ay equals negative bx plus ab, right?
Yeah.
Or you can say ay plus bx is equal to a, okay?
Yeah.
Okay, so a can be from what to what?
A can be from 0 to 1.
Do we consider a0, for example, consider this line?
Well, like greater than 0, right?
Does it belong to f? It says greater than 0, unit lying in the first quadrant with p on the x-axis, q this is the unit. In the first, well, it is on x-axis, but it is not important because we shouldn't consider AMG, right? We can consider greater than equal to 0, less than or equal to 1. Because for a0, it considers this one. For a1, we consider this point, right?
Yeah.
Okay, so a, b are not our answer. We want to find c. So now we should find coordinate of these in terms of a and b, okay? Then
Yeah.
we can say this coordinate can be from what? Okay? So find these two question marks. Let me call this, for example, CD. What are CD equal to in terms of a and b? Try.
Okay, so I got that C is equal to AB minus A through 2.
C is equal
All
to
A times B
a,
minus A root 3 over 2. All of that over B minus root 3A.
this one, right?
Yeah.
Okay, so let me check it. Here, we know ay plus bx is ab. So for this one is 1 half, a is 1 half. So 1 half y plus b is root 3 over 2. Root 3 over 2 x is equal to the product root 3 over 4. And if you check it, if you plug in 1 half for x, 3 over 4 for y, root 3 over 4. Okay, so now we should find x and y for c and d. If you want to find y, so let's do something. Let's write multiply this one by a, this one by 1 half to get rid of y. So it will be ay over 2 plus bx over 2 is equal to ab over 2. And for this one, ay over 2 plus ax root 3 over 2 is equal to a root 3 over 4, right? If you subtract, you said x is b. Okay, so if you subtract x times b over 2 minus a root 3 over 2 is equal to ab over 2 minus a root 3 over 4. So to get rid of the denominators, we can multiply by, if we multiply by 2, then we have only this. So ab minus a root 3 over 2 over b minus a root 3, yes. So C is this and D is, okay, so let's focus only on C. So this C, look, it says there exists exactly one C that is not possible, right?
Yeah.
It means that, let's consider different A's and B's. If you consider, for example, A equals 1 half, and then B equals root 3 over 2, right?
Yeah.
Then in this case, C is equal to what? Root 3 over 4, right?
Yeah.
minus a root 3 over 4 over b minus this root 3 over 2 minus root 3 over 2. It's 0 over 0, right? It's
Yeah.
undefined, but we can, and we know it would be this line, and we don't need to check that line, right?
Yeah.
So without loss of generality, we can consider a. We know is from strictly 0 because again we know 0 is this one is between 0 and 1, and a is not equal to 1/2. And we know that a squared plus b squared is 1. And again, b also is between 0 and 1. And c is this one, so c doesn't cover one value. Okay, and we know c is from 0, strictly from 0 to 1, because we don't consider this line and this line, right? And this line. So from 0 to 1, this expression doesn't cover one value, right?
Yeah.
Okay, so one way is to write it in terms of only a. Okay, for example, write b in terms of square root of that. One way is that. One way, for example, is to see that, for example, when the denominator is 0, it would be bad, right?
Yeah.
Do we have any other value? So we know when a is 1/2, the denominator is 0. Do we have any other value that a is not 1/2 and this one is 0? Try these cases, see if you can find any of them. If not, let me know to give you a hint, okay?
Okay. It's only 1/2 for positive A values.
Only 1/2 is for the case that this is 0.
Yeah.
b minus a root 3 is 0, so b is equal to a root 3, and a squared plus b squared is 1, right? So 4a squared is 1, so a is 1/2, right?
Yeah.
Okay, one value is that. What about, for example, one case that... So let's do something. For example, we want to see, is it possible to be 1/3 or not, okay? So suppose, for example, c is 1/3. Try to find corresponding a. When we check for 1, 2 values, and we get, for example, in which part, for example, we have a denominator 0 or something like that to find that part. Understood?
Okay. But why are you trying to
Okay.
get denominator 0?
Because we should find something, for example, if we have a square root be negative. We want to see something that is not possible, right?
Okay.
One approach is denominator 0. And when you check 1/3, in general, we should calculate a and b in terms of c, okay?
Okay.
Then, so, for example, consider it is 1/3. Now find a and b. Okay, so let's try it
Okay.
together. We want to see, is it possible to be 1/3 or not, okay? Let's solve it. Here, if we cross multiply 3ab minus 3a root 3 over 2 is equal to b minus a root 3, right?
Yeah.
Okay, so here I'm thinking of something. You know, a and b are related to each other, right? A squared b squared is 1. I agree.
Yeah.
So if we over a, okay, so if we want to find a, we can calculate b in terms of a, right?
Yeah.
So it will be 3a minus 1 equals to 3a root 3 over 2 minus a root 3, right?
Yeah.
So b is equal to a root 3. This one would be what? If we simplify, a
A
root
root
3
3 over
over 2,
2.
right?
Yeah.
So a root 3 over 2 times 3a minus 1, right?
Yeah.
So a squared plus a root 3 times 2 times 3a minus 1 squared is equal to 1. So what can we say here? It would be a quadratic equation, right? 3a squared. So what part is hard?
What,
You were not able to solve it.
what can you see your work again? What do you do?
Here it would be 4a squared is equal to 4 times
Can
9a squared,
you scroll up?
36.
You
Let's
scroll
scroll
up
up.
and see.
Yes. More or that's enough?
Yes, that's good. Really good.
Here also we can divide by 4a squared, 4. Then a is equal to plus minus b.
You didn't do. Wait. Wait. Oh, never mind.
A is equal to 1/4. Seems 16 root 15 over 4, right? So we can plug in and check, okay? In the end, we will check it to make sure to not make any careless mistake. So here, AB, it will be root 15 over 16, right? Minus a root 3, it's root 3 over 8. Over b, root 15 over 4. Minus root 3 over 4, right?
Yeah.
So we can cancel these 4s. It is 2, it is 4. And, okay, so if you cancel 8, it would be what? 2 root 15 minus 2 root 3, right? Over root 15 minus root 3. So we can cancel root 3, it would be root 5 minus 2. All over 8, root 5 minus 1, right?
Yeah.
Is it 1/3? I don't think so. So let's check it again. 3ab minus 3a root 3 over 2 is equal to b minus a root 3. b times 3a minus 1 is correct. 3a root 3 over 2 minus a root 3. So 3 minus 2 is a root 3 over 2. Agreed this? So b is
Yeah.
equal to a root 3 over 2 times 3a minus 1. So if you can say a squared plus a root 3 over this one is equal to 1. So a squared plus 3a squared equals 4. 3a minus 1 squared. So a squared plus 3a squared. I found my
But what
mistake.
about this
Here I
second
should
to the
multiply this. Erase this part. Okay, so here it would be a squared 4a squared times 3a minus 1 whole squared, right?
Yeah.
Plus 3a squared is equal to 4 times 3a minus 1 squared, right?
Yeah.
Okay, can we simplify this?
Well, this is a quartic equation now. So
Yes.
it's like,
And also it has, for example, a cubed, right? If
yeah.
you didn't have a cubed or coefficient of a, it was okay. So is it and look here, we want to see only is there a good a that satisfies this or not. Okay?
Uh-huh.
But it would be it harder to. So 4a 3a 9 times 4 36 a to the fourth, right?
Yeah.
Okay, so one way is to define A and B. One way is that last year I solved this instead of equation that is related to A and B, because look, A and B are related with A squared B squared, right? And that equation is not so much good. How can we write this equation? Instead of defining A and B, we can consider another variable and write the equations in terms of that.
Like an angle.
Let me see. Can you say it again?
The angle.
Exactly. What's this angle equal to?
That was 60.
Yes. What's this angle equal to? For example, let's call it O. Okay. Now we can say what are the coefficients of A and B. This one is 0 and what?
As a function of alpha.
Yes.
Sine alpha.
Exactly. What about x intercept?
Cosine alpha.
Cosine alpha is and 0. Okay, what's the equation of this line? Pink line.
Sine alpha y plus
Or y equals, if we consider this point, what's the slope?
y equals negative tangent alpha x plus sine alpha.
This one, right?
Yeah.
Okay, so now we have only alpha, and we don't need to use Pythagorean theorem. What can we say about this equation? We've
Y
calculated
equals
this before, right? Y equals negative what?
y equals negative 3x plus root 3 over 2.
Negative, the slope is negative root 3, right?
Yeah.
Times x minus 1 half, right?
Yeah.
Okay, now the intersection is CD. Here we are working only with alpha, not with two variables a and b, right?
Yeah.
That's why it would be easier. So use the same approach like the previous one and try to see and calculate C and see for which C it's impossible to reach that, okay?
Okay. Divided by tangent theta minus root 3.
Let me write C is equal to
Sine theta minus root 3 over 2.
sine theta, you
Theta
said?
or alpha.
Sine
Alpha.
alpha, then what? Root 3 over 2?
Minus root 3. Yeah, minus root 3 over 2.
Okay.
Divided by tangent alpha minus root 3.
Divided by tangent alpha minus root 3, right?
Yeah.
Okay, so we want to see it covers which value. So let's solve it again for 1/3, okay? So 3 sine alpha minus 3 root 3 over 2 is equal to tan alpha minus root 3, right?
Uh-huh.
What can we see here? It's not so much easy to calculate alpha, right?
Yeah.
But let's do something. We know this function is continuous, right? If you don't consider, for example, zeros of the denominator, it is continuous, right?
Yeah.
So let's consider the endpoints. For example, if alpha is 0 is for this one, alpha 90 is for this one, right? When
Yeah.
alpha is 0, c is equal to what?
Over 0, c is equal to negative root 3 over 2, 1/2. But no,
It's what?
1/2.
Yeah, because it is 0. 0, if you divide it, it would be 1. So when alpha is 0, it's to start from 1. Now, if maximum alpha is what?
90.
Yes. What about 90? What's for 90? What's this one equal to?
Well, it's not really defined, right? The tangent 90.
It's 1 minus root 3 over 2. Tangent 90 is infinity, right?
Yeah.
So it is equal to what?
0.
So as you can see, because C lies on this one, do you agree C can only be from 1/2 to 0?
How do you know it's like, how do you know it can't increase like between 0 and 90 degrees? How do you know just from the endpoints that everything else is between that?
No. I said the intersections. If you calculate C is the intersection of this fixed line and this one. This intersection can be from 1/2 to 0 in general, right?
Okay.
I didn't consider this function. I said the intersection of this line. Okay, we consider the geometry of this. Okay,
Okay.
and we know this, but we should pay attention to function. If we, for example, if we didn't have this in the denominator in the numerator, we know that this is continuous, right? This function is continuous, so it covers from one half, and this one can be, you can be as near as you want to zero, right? And for a, we know
Yeah.
this line is good, and the problem says except a, right?
Yeah.
So we can cover all points near this, right? And
Yeah.
we can cover one half. So you should see between them which point is impossible to reach, right?
Yeah.
So because this function is continuous, yes, you can say, for example, 1 half 0, maybe it can go to something greater than that. And it's not important for us that it covers something more than this part or not, okay?
Okay.
But we know it covers this one and near this one, and we can consider this. So we want to see it doesn't cover which part. So do you agree when we want to see which part it doesn't cover? So we should find a problem here, a discontinuity, right?
Yeah.
It can be in the position that tangent alpha is undefined, but tangent alpha we know in 90 is undefined. Between 0 to 90, it has some variables, right?
Mm-hmm.
So can you tell me we should consider which point? Only one point from 0 to 90 degrees is bad for this function.
Uh, 60 degrees. 60 degrees.
Exactly. So check 60 degrees and see in 60 degrees, 60 degrees causes to not cover which point, okay?
Wait, what do you mean?
So look, alpha 60 is bad, right? We cannot use alpha
Yeah.
60 because the denominator is 0. Use these to
Yeah.
see it doesn't cover, because the problem says it doesn't cover one point, right? We proved
Yeah.
from here that it covers near this, and we shouldn't consider A and B. And from here we considered it covers near one half. So probably near alpha 60 we have some problem, or in alpha 60, right?
Okay.
Because for all other parts it is continuous. So focus on this one and see if you can find the bad point.
Okay. So what I did was I just took the limit as alpha went to 60 degrees of C, and I got that to be 1 over 8. So
Uh, Alpha 60, it is 1 over 8, right? How did you calculate when alpha 60 sees this one is 1 over 8?
L'Hopital's. L'Hopital's.
Oh, exactly. So if alpha is 60, then we can say this part sine alpha, it is 0 over 0, right?
Yeah.
So if you use Hopital rule, it will be cosine alpha over 1 plus tan squared alpha, right?
Secant squared. Yeah.
Uh,
Secant squared.
so yes, secant squared. So 1 plus tangent squared is what?
Secant squared.
Yes, secant squared is this one. It's 1 plus tan squared is 3. So it's 1 over 8, right?
Yeah.
Secant squared is 1 plus tan squared, okay?
Yeah.
So 1 over 8. Now, prove that in AIME, you can plug in and solve the answer. But here we want
Yeah.
to prove that why this one cannot be equal to 1 over 8. Okay?
Okay. But
Try.
graphically I don't fully understand what's happening. Like
Okay, so
as
look, we've not proved. Here, we said, okay, it is a continuous function. If we didn't have this denominator, do you agree it covers from any two values? It covers all the values between any two, for example, real numbers, if you didn't have this denominator?
yeah.
When you have a continuous function, for one value it is 1 half, for one value it is 0, it covers all values between them. It's not important that it goes like these. It covers all values between them, okay?
Okay.
Okay, so Because it is continuous function, the only points that we can consider them as discontinuity is when the denominator is 0 or when tan alpha is undefined. But we know from 0 to 90, tan alpha is defined, right? Is not undefined. So the only points that we should consider is when the denominator is 0, and we found for 60 we have this, right?
Yeah.
So it is the only point that we can say we cannot cover this, right?
Yeah.
But now we want to find a rigorous proof to prove that we cannot cover 1 over 8. No values of this is 1 over 8, okay?
Okay.
So try bit on your own, see if you can prove it, that this one cannot be equal to 1 over 8.
Okay, so if you just set it equal to 1/8 and cross multiply it,
Why you're can you say it again? Oh, now it's okay.
if you set it equal to 1/8 and cross multiply, then you can get 4 sine A minus tangent A equals 3 root 3. And then
Okay, so if you consider 1, 8 sine alpha minus 4 root 3 is equal to tan alpha minus root 3, right?
oh,
Agreed?
oh yeah.
So 8 sine alpha minus tangent alpha is 4 root 3 minus root 3 is 3 root 3, right?
Yeah.
Then what?
I made a mistake. Uh, how do I prove that this is not possible?
Okay, do you need a hint?
Yeah.
Okay, so look, we know that alpha 60 works here, right? Because it's 8 over 2, 8 root 3 over 2 minus root 3 is 4 root 3 minus root 3, right? Alpha 60 works because of you, right?
Yeah.
Okay, if we take there, so we can consider this this function is f of alpha, right?
Yeah.
What's f prime of alpha is, what's f prime of alpha equal to?
8 cosine alpha minus secant squared alpha.
Yes, or 1 minus cosine squared alpha, right? So agree.
Yeah.
So cosine squared alpha, 8 cosine cubed alpha minus 1, right?
Yeah.
So the denominator is always positive, right? Because alpha is from 0 to 9, right?
Yeah.
What can we say about the numerator? You know, cosine alpha also is positive between 0 and 1, right?
Yeah.
So if you want to see in which position it's positive, so you say this. So cosine cube and cosine alpha is greater than 1/2, right?
Yeah.
So it means that alpha what? And cosine alpha is greater than 1/2.
Less than 60.
Exactly. So for less than 60, what can we say? Alpha is alpha f prime alpha. 0, 60, 90. What can we say about 0?
When alpha is 0, f prime is negative. It's
We don't
undefined.
need to consider. For 60, it is what?
At exactly 60.
0, right?
Yeah.
Before 60, it's positive or negative?
Um, greater than 1/2, so it'll be positive.
Positive, this one negative. So f here is increasing and then decreasing, right?
Yeah.
So from 0 to 90, do you agree in one position only f of alpha can be equal to 3 root 3, right?
Yeah.
Here, before that, it's less than that. After that, it is greater than that. So f cannot be equal to 3 root 3 for any other value except 60, right?
Yeah.
So we cannot reach to 1 over 8 for this one, right?
Yeah.
Okay, so alpha 60 is the only value that you can reach 1/8. So because alpha 60 is not possible for this, because when alpha 60 is this one, alpha 60 will be this line. Agreed?
Yeah.
We cannot use this line. Because we cannot use this line, which is 60, so we cannot cover 1/8. So C is 1/8, right?
Yeah.
Okay, so that C is different from this C. It is big C is 1/8 and what?
1/8. 3√3/8.
X squared plus y squared is 1. So 64 with 63, isn't it this one?
No, it's not. It's not a squared plus
Oh,
b
yes,
squared.
it's not. Sorry. So we should plug in 1/8 here, right?
Yeah.
Okay, if you plug in 1/8 here, so -√3, 1/8 minus 1/4. So it would be 1 minus 4, -3, so it's 3√3/8, right?
Yeah.
Okay, 3√3/8, so what's the answer equal to?
64 over 27. 64 23.
So it's what over what if you simplify?
7/16.
Yes, 28/64, which is 7/16, 23. Okay, understood?
Yeah.
Okay. What's your next question?
Actually, on this question, can you kind of explain like what's happening as the kind of like angle approaches 60 degrees? I don't like fully understand what's
For this
happening
one?
graphically. Yeah.
Okay,
Like
so
why is this 0.18 like?
okay, so look, we consider the endpoints, okay? For one, we want to see between 1/2, between 0 and 1/2, we cannot cover which of them, okay? And the problem says A and B are not important, so from 0 to 1/2 open interval. We want to see we cannot cover which of them, okay?
Okay.
We can say something, let me tell you like this. You can say, when you calculate this, you can say alpha can be, for example, look, when it is this one, alpha is 0. And when you increase it, it starts from 0, right?
Yeah.
To 90. So alpha belongs to 0 to 90, right?
Yeah.
But we agree the problem says we shouldn't consider this line, right? Let's consider
Yeah.
like. So do you agree alpha cannot be equal to 60? We cannot
Yeah.
consider this. So we can use all alphas except alpha 60. When you use alpha 60, you can see it would be 1/8, okay?
But if alpha were 60, wouldn't it just be the same line?
Yes, it would be the same line. Because all alphas are different. Because when you move it, alpha will be greater, right?
Then where does the 1/8 come from?
Because
It's
because the agree sees this when we consider intersection of these two lines.
yeah.
So when you consider alpha 60, if you calculate this by Hospital's rule, C is 1/8.
Okay.
Okay, so then we should consider, does any other alpha create 1/8 or not? Okay, so we consider, let's consider this 1/8, we cross multiply and we saw that it's impossible to create 1/8 except alpha 6.
Okay.
Okay.